Now that you know why and how the Wathba 2 and Al Hamah plants have been built, you will soon find out how they work. Each day in the Emirate of Abu Dhabi, each inhabitant produces approximately 300 liters of household wastewater from bathrooms, showers, kitchens, and more. This wastewater needs to be treated to avoid pollution of the environment and recycled into irrigation water to keep the emirate luscious and green. This wastewater is treated in 3 steps. The first step consists of removing all the pollutants from the wastewater to transform it into irrigation water. This step produces sludge, which is treated and transformed into biosolids suitable to be used as soil conditioner and fertilizer in agriculture. These treatment steps generate odorous air, which is collected and treated in a specific process. Now let us guide you through the complete process of the treatment from A to Z. Delivery and lifting of wastewater. Wastewater is conveyed from the city of Abu Dhabi by 40 kilometers of buried pipes. The flow reaches the plant through a 2-meter diameter pipe laid at 18 meters below ground level and is monitored continuously by means of an electromagnetic flow meter. Wastewater then flows into the inlet chamber where large objects are trapped to help protect the equipment downstream. The trapped objects are periodically removed by a grapple mounted on a beam and are sent to landfill for disposal. The inlet chamber also has an emergency overflow arrangement to deal with unforeseen circumstances. Wastewater then passes through 3 coarse screens whose purpose is to hold all objects larger than 5 centimeters in order to protect the pumps located downstream. The objects screened are then collected by a belt conveyor and sent to landfill for disposal. Wastewater is then pumped 23 meters higher by 5 submersible pumps to allow the flow to circulate by gravity throughout the plant. Each pump can lift up to 5,000 cubic meters per hour and has its individual rising main. The water is then sent to fine screens to be further treated. Inlet chamber, coarse screens, and pumps are enclosed in buildings where a negative pressure is kept to avoid the air to flow outside the buildings and lead to odorous nuisance. The air inside the buildings, loaded with H2S, which is a lethal gas and very corrosive for equipment at high concentration, is continuously renewed to allow operators to work in the building, and the air extracted is sent to the odor treatment units. Preliminary treatment. Wastewater is firstly treated to remove small objects, grits, sand, grease, and any other floating materials. This begins with a fine screening process where 4 fine screens trap any object larger than 6 millimeters. The screenings are collected via a screw conveyor and compacted to half their volume before being dumped into waste skips and sent to landfill for disposal. After fine screening, wastewater is conveyed to the 4 grit and grease removal tanks where the water velocity is controlled to allow settlement of sand and grit. The scraping bridge is equipped with a bottom scraper to remove the sand and grits settled at the bottom of the tank, and with a skimmer to remove the grease floating at the water surface. When the bridge travels from left to right, as shown here, it is lifted to be at its high position and skims the oil and grease at the surface. When the bridge travels from right to left, it is pulled down to be at its low position and scrapes the sand and grits at the bottom. Grits and sands are pumped out towards sand classifiers to be washed and sent to landfill for disposal. Grease is concentrated in a specific chamber and then sent to landfill for disposal as well. This treatment stage takes 15 minutes. Fine screens and grit and grease tanks are enclosed in buildings where a negative pressure is kept to avoid the air to flow outside the buildings and lead to odorous nuisance. The air inside the buildings loaded with H2S, which is a lethal gas and very corrosive for equipment at high concentration, is continuously renewed, and the air extracted is sent to the odor treatment units. Primary treatment. The pre-treated wastewater flows then through 6 primary settling tanks, where nearly 50% of suspended solids and 20% of BOD5 is removed. This treatment step uses Veolia Water's patent multi-flow mono. The wastewater flow arrives at the bottom of the structure and circulates at countercurrent along inclined lamellas, where the suspended solids settle and slide down by gravity. The settled material forms the primary sludge, which is collected by mechanically driven scrapers towards a hopper at the base of the tank, where it is pumped to the sludge treatment building to be thickened. Primary settling tanks are covered. Negative pressure is maintained by permanent extraction of the air inside the tank, which is then sent to the odor treatment units. This treatment stage takes 1 hour and 30 minutes. Secondary treatment. Secondary treatment is the heart of the wastewater treatment process. Whereas the previous steps of treatment consisted in removing the suspended solids by settlement, this step of treatment consists in removing the major part of dissolved pollution, mainly BOD5 and ammonia. During the aeration phase, specific bacteria eat the dissolved organic matter and transform it into suspended solids. Other specific bacteria oxidize the ammonia into nitrates, then nitrates. During the non-aeration phase, called also anoxic phase, other type of bacteria convert the nitrates into nitrogen gas, which is released into the atmosphere. To ensure a good balance between food and bacteria, the bacteria settled in the clarifiers are continuously returned at the inlet of the tank. They are called return-activated sludge. The upstream part of the activated sludge tank is covered so that odorous air is trapped and extracted towards odor treatment units. Clarification. Water from the activated sludge tanks flows into 6 clarifiers. In the clarifier tanks, the mixed liquor from the aeration tanks is fed at the edge of the 50-meter diameter circular tanks along the circumference and not at the center like in conventional clarifiers. This allows a higher surface loading rate and smaller tank size. During the clarification process, the low water flow allows the settlement of the solids and microorganisms forming the activated sludge. The scraper bridge is equipped with a vacuum suction system which sucks the sludge at the bottom of the tank. The necessary quantity of this sludge is returned to the activated sludge tanks, as explained earlier, and the excess is sent to the sludge treatment building. The clarified water runs off to further treatment process. This treatment stage takes 5 hours and 30 minutes. Filtration and disinfection. This stage of treatment is necessary to produce water suitable for irrigation purposes. Filtration consists of removing residual suspended solids that are larger than 10 microns. The water passes through a dual media filter consisting of a 1.4 meter layer of pumice and 0.6 meter layer of sand. There are a total of 14 filters. During the filtration process, the suspended solids present in the water are trapped by filtration media. The last stage of water treatment consists in the disinfection to ensure that the concentration of bacteria is substantially reduced. A solution of sodium hypochlorite, commonly called bleach, is injected into treated water just after the filtration step. The contact time of the filtered water with the disinfected agent is 1 hour. The disinfected water, which at this stage can be called recycled water, is then pumped to the final effluent reservoir before being sent to the city of Abu Dhabi for irrigation purposes. Sludge treatment. The primary sludge extracted from the primary settlers and the excess activated sludge extracted from the clarifiers will follow 4 stages of treatment: thickening, anaerobic digestion, dewatering, and drying, to be finally transformed into a valuable resource called biosolids. Primary sludge and excess activated sludge are firstly mixed together before being injected in a flocculator where they will be mixed with polymer. In the flocculator, the particles of sludge will be absorbed on the polymer molecules to form flocks, which will facilitate the drainage of water later on. After this, the flocculated sludge flows into the rotating drum filter where part of the water contained in the sludge is drained. The filtrates are returned to the water treatment system to be treated. At the end of this thickening process, the concentration of the sludge reaches 60 grams per liter and looks like liquid mud. Treated water is sprayed permanently at high pressure on the drum to avoid any clogging and maintain the thickening efficiency of the equipment. Polluted air is continuously extracted from the drum and sent to odor treatment units. Anaerobic digestion. The thickened sludge is pumped into the anaerobic digesters. This step aims at stabilizing the sludge and consists in the destruction of volatile organic matter by anaerobic bacteria in the absence of oxygen. The process is a mesophilic digestion in which sludge is fermented in tanks at a temperature of approximately 36 degrees Celsius and mechanically homogenized by a mixer. This sludge remains at least 15 days in the digester to ensure proper reduction of volatile organic matter. This process generates biogas with a high proportion of methane, which is partly used by the boilers to heat the sludge and maintain the digester at a temperature of 36 degrees Celsius during the cooler season. The unused biogas is stored in the gas holder and then burnt into flare. The sludge from the primary digesters gravitates to the secondary digesters, which serve as buffer tanks before dewatering and act as sludge degassing. Dewatering. Digested sludge is pumped into the centrifuge in order to achieve a dryness of 24%. Polymer is injected to the sludge upstream of the centrifuge to create flocculated particles and improve drainage. The centrates are returned to the water treatment system to be treated. The dewatered sludge falls down into skips that will be emptied on the solar drying beds. 140 tons of dewatered sludge are produced every day. Polluted air is continuously extracted from the centrifuge and sent to odor treatment units. Drying. The dewatered sludge is downloaded on solar drying beds equipped with mechanical returning machines which turn at a speed of 40 rotations per minute and move back and forth. This allows the sludge to move forward by 3 meters per day and to expedite the drying. After 30 days, the sludge reaches the end of the drying bed with a minimum dry solids content of 85%. The sludge, which is called biosolids at this stage, is then stored on the dedicated area of the drying bed before being collected by ADSSC in charge of its disposal or reuse. Odor treatment. The air polluted with sulfurous compounds such as the hydrogen sulfide gas is extracted from various areas of the plant and is conveyed through ventilation pipes to the odor treatment building. The odor treatment process consists of both biological and chemical scrubbers. The air flows firstly in the biotrickling filter through a media on which microorganisms are fixed. These microorganisms feed themselves with the odorous compounds and this way clean the air. To keep this biomass alive, the media is kept humid by means of treated water which is sprayed on top of the media. Biotrickling filters do not require chemical reagent and improve significantly the environmental impact of the plant. Then the partially treated air flows consecutively in 3 chemical scrubbers, inside of which a mix of soda and bleach circulates through a media and reacts with the air flowing up to fix the odorous compounds. The reagents are continuously recirculated to optimize chemical consumption. Fresh reagent is periodically injected to replace used reagent, which is drained and returned to the water treatment system to be treated. 144,000 cubic meters of fouled air is treated every hour, and 600 kilograms of hydrogen sulfide gas is removed every day. Now that the wastewater treatment process no longer holds any secrets for you, you're welcome to visit our plants anytime to enjoy the live experience of water treatment.